Greetings and welcome to Lesson 1.6, Multiplication of Real Numbers. We're going to look at the rules and a few examples on multiplication of positive and negative numbers. In this first portion of this video, we're just going to look at it to see generically what result will I get. Now I have four options when I'm multiplying real numbers. A positive times a positive, a negative times a negative, a positive times a negative, and a negative times a positive. So I have four options when I'm multiplying real numbers. Now the first option, the positive times the positive, is pretty straightforward when you want to explain what's happening. So if you remember, multiplication is the shorthand of addition. So if I have 3 times 5, that means it's going to be 3 plus 3 plus 3 plus 3 plus 3. So I have 5 3's, right? And if I say 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 3 is 12, and 12 plus 3 is 15, that's 15. But the important part here, besides 15, is that it is a positive 15. So a positive times a positive will give me a positive. Now the negative times a negative is a little weird to explain it, but here's how I'm going to explain it. If I wanted to rewrite it like the positive times positive, but now I'm negative times negative, what I have to do is I have to carry this negative from the 5 along with the negative 3's. So it becomes the negative negative 3, negative negative 3, negative negative 3, negative negative 3, and negative negative 3. But negative negative 3, another way of saying that, is the opposite of negative 3. And the opposite of negative 3 is positive 3. And therefore, it really is positive 3 plus positive 3 plus positive 3, and so on. So my result is 15. But more importantly for this exercise, my result is positive. So a negative times a negative will multiply to a positive. Positive times a negative, well, that's going to be a positive 3 times negative 5. I can write negative 5 3 times, and that will give me a negative 15. So negative 5 plus negative 5 plus negative 5. That will result in a negative result. And then a negative times a positive, the cool part about that is we have that nice rule that property of the commutative property means I can switch it around. So a negative 3 times 5 is the same thing as 5 times negative 3. And if that's the case, I write negative 5 times, I add them up together, and I get a negative 15 as the result. So here's the rule. 2 positives will result in a positive result. So if I multiply 2 positives, it comes out positive. 2 negatives, if I multiply 2 negatives, it comes out positive. 1 negative, 1 positive will result in negative. 1 positive, 1 negative will result in negative. So if the signs are different, it's negative. But what happens if I have more than 2 numbers? Then what? Well, the cool part about that is that a positive times a positive times a positive times a positive times a positive, doesn't matter how many positives you have, that will result in positive. What happens is when you throw in any negatives in there. Here's the trick, or the rule of thumb, if you want to call it that. Depends on the number of negative signs. So if I have an even number of negatives, my result is going to be positive. Why is that? Because if I have 2 negatives, then that's going to result in a positive. As soon as I throw in 1 more, then that's negative times negative is a positive, and now I have a positive times a negative, that's a negative, right? So an even number of negatives will result in a positive. Odd number of negatives will result in a negative. The cool part about that is I can have a whole long line of numbers and it's all multiplication, and I want to know what the solution is. I can handle the sign of the result right in the front, right in the beginning. And as soon as I take care of the sign, I don't have to worry about the sign anymore. Now I just multiply all the numbers together. For example, -1 times 2 times -3 times 4 times -5 times 6 times -7. Well, I had 1, 2, 3, 4, 5. I had 5 negatives. My result, doesn't matter what it is at this point, it's going to be negative. Now that I dealt with the sign, now I just multiply all the numbers up. Okay, so that's how I use, I don't have to carry along the sign and worry about the sign. I can take care of it first and foremost, and then I don't have to worry about it anymore. When multiplying fractions, if you recall, you're going to multiply all the numerators of all the fractions, and that becomes your results numerator. When you multiply all the denominators together, that becomes your results denominator. But you also now need to apply the rules of the signs as well. For example, a -3/4 times 5/7. What that becomes is -3 times 5 is -15. 4 times 7 is 28. So the result is -15 over 28. To multiply -6 by 1/2, remember, any whole number there's an implied 1 in the denominator. So it's -6 times 1 becomes -6. 2 times 1 is 2. -6 over 2 we can reduce to -3. So our solution is -3. When we have two fractions and they're both negative, it's going to be -2 times -3. That becomes a +6. Negative times negative is positive. And then 3 times 2 is 6. A +6 over 6 is 1. So I have a cool example here how you would use negative numbers in the real world. So let me just switch over to our text. So there are a couple of graphs here. One is a graph of how many calories you burn depending on what activity that you do. And then the other one is if you eat something, whatever food it is, how many calories are in that food. So how would we use negative numbers in this case? So when we exercise, we burn calories. That's a negative calories, right? It goes out of our body. Think of it like that. When we put food in, it goes in, it's a positive number. So for example, let's say if a 150-pound person, let's see, spent 1 hour of exercise and, let's see, what did he do? He played handball for 2 hours, okay, but then he ate a Whopper. So how many calories total was that? Well, for handball, it's 680 calories per hour, and for Burger King Whopper, it's 630 calories for the food. So we have a positive 630 calories for the Whopper minus 2 hours times however much handball is, which was 680, which yields 2 times 680 is going to be 1,360, and 630 minus 1,360 is a grand total of negative 730 calories. So what does that really mean? It means that we burned, even after eating a Whopper, this person burned 730 calories. His net change was negative. So negatives do really exist out in the real world. In the previous video lecture, we chatted about the associative property of multiplication and how does that work. Well, technically, we're only allowed to multiply numbers by numbers. Letters are variables and they just kind of come along for the ride. We're doing something, but when we're working with a letter, it's coming along with it. For example, negative 3 times the quantity 2x. Well, I can use my associative property to regroup it to where the numbers are together. So negative 3 times negative 2. Well, negative 3 times negative 3, well, I can do that. That's negative 3 times negative 2 is negative 6. So my final answer is negative 6x. For another example, I have 6 times the quantity negative 5y. By using my associative property, I can regroup it to where the numbers are together. Now it's 6 times negative 5 times y. 6 times negative 5 is negative 30. So my final is negative 30y. The third example I have is negative 2 times the quantity negative 1/2 x. Again, I'm going to regroup it to where my numbers are together so I can do that multiplication. Negative 2 times negative 1/2. Well, negative times negative is a positive, so I can deal with the sign first. Now, 2 times 1 is 2, 1 times 2 is 2, 2 over 2 is 1. So our final answer is x in that case. The last thing I want to chat about very quickly is geometric sequence. What geometric sequence is, you get a list of numbers, and then after the first number, the following numbers come from multiplying it by the same amount each time. So, for example, if I give you 2, 6, 18, 54, each time I multiplied the next number by 3. So it was 2, and then my next number is 2 times 3. My next number is, in essence, 2 times 3 times 3. My next number is 2 times 2 times, or 2 times 3 times 3 times 3. Following number will be another set of 3's. So I know by this first example, my very next number is going to be 54 times 3. And remember, another way of looking at that is going to be 2 times 3 times 3 times 3 times 3, because I just multiply it one more time by a 3. So there's another way of looking at it using exponents, but I'm going to jump across that because this class is going to focus on that. So let's go ahead and check out some examples. So we have 5, 10, 20. What would be the next number? Well, if I think about it, I said 5 times something will get me 10. Well, that was 2. 10 times 2 will get me 20. 20 times 2 would get me 40. 40 times 2 would get me 80. So my next two numbers are 40 and 80. Now let's look at the next one. 3, well, now I have a negative 15, and then I have a positive 75. What? Well, the only way from a 3 to get to a negative 15 is to multiply that by a negative 5. Okay, that makes sense. So if I multiply negative 15 by a negative 5, would I get a positive number first, and would I get a 75? And indeed, yes. So my next value is going to be 75 times negative 5. That's going to be a negative 375, I believe. And this also works with fractions. Well, 1/8 times something will give me 1/4 times something will get me 1/2. Now, the cool part about this is I don't have to multiply it by a fraction to get to the next one. I think I multiplied it by 2. Because if I did, then that gives me 1/8 times 2, but that's 2 over 8, which equals 1/4. And that was my next number. If I multiply 1/4 by 2 over 1, that gives me 2/4, but 2/4 is really 1 over a half. So it looks like that pattern is working really well. So what's 1/2 times 2? Well, my next number is 1. Now, it's 1 times 2 is 2. 2 times 2 is 4. So that's geometric sequences. You just got to figure out what is it multiplying to get to the next number. It could be negative. It could be a fraction. It could be positive. It could be a big number. It could be a little number. So just think about what happened to that first number to get to the second number, and that usually will start your pattern. So until next time, be seeing you.